Good afternoon, everybody. I want to thank everyone for joining us today for today's web event. The focus being StarWind Software's high availability storage solution in combination with VMware ESX or vSphere 4. Just to give you a quick overview of sort of what we're going to cover today, and those of you that have heard me speak will have seen some of this before, so there'll be a little bit of overlap. But an overview of SAN technology. We're going to talk a little bit about the traditional fiber channel technologies and some of the traditional storage area network technologies that are out there today. We're going to start to really start the discussion around the iSCSI SAN itself, really dig into some of the benefits around the iSCSI SAN. From there, we're going to take a quick step back and we're going to talk about SAN versus direct attached storage. A lot of you may be wondering, why should I bother implementing a storage area network when I've got plenty of direct attached storage? So we're going to discuss some of the benefits of the SAN itself. SAN software, using SAN software to build out a shared storage infrastructure. We're going to touch on that. And then we're really going to get into, now that we'll have talked about all of the different types of shared storage technologies, why iSCSI, why you should consider iSCSI, what are the benefits of iSCSI in terms of, a cost factor along with some of the other management factors that go into, why iSCSI is the right solution for this type of scenario. And then we're going to really, get into some of the details around iSCSI for ESX and a small business or small to medium business. The shared storage requirements, why are they there? What do you need shared storage for when implementing, an ESX solution or a virtualization solution using VMware? A short overview of ESX itself, sort of what it looks like in the environment. For that, I've got a couple of network diagrams that I want to share with you, connecting shared storage to your ESX environment and the benefits that go along with that. And then ultimately, start to really get into the high availability scenario. So not only will you have in your ESX resource cluster the ability to make your VMs highly available, spread across multiple hosts, but you'll be able to do the same thing with your storage via MPIO. And then we're gonna really put the theory into practice. This is where I'm going to cut over to my demo lab and really show you how this is working in a live environment or live situation, so you can get a better flavor for how to go about getting this set up, what's needed, how to configure the software on both sides of the equation, both on the storage side and then on the ESX side as well. So with that said, let me go ahead and sort of kick things off. Now, I always like to start these discussions out with a conversation around the traditional storage area network scenario, which in the past has been fiber channel. So for a lot of you, this has simply kept you out of the shared storage market. I know that I've worked for several organizations prior to coming to StarWind where we've wanted to utilize the shared storage. Couldn't quite wrap our heads around how we were going to make it work financially. And as you can see there, one of the things that we're talking about here is a lot of proprietary hardware. So a lot of hardware that you're simply just using for the purposes of this storage area network. So fiber channel HBAs, fiber channel switches, and then ultimately the fiber channel SAN itself. So, a lot of cost associated with getting something like this in-house for the first time. Now, obviously, the idea or concept of separating out the application layer from the storage layer and managing that storage layer as a separate entity was something that was pioneered by some of the vendors in this industry. So for that's excellent. I think those are the concepts that we can take away from this. But I think that for a lot of us out there, the idea of simply going out and making an investment in some of this hardware and then the ongoing management of a setup like this is just too costly to consider. And so for those folks, and for those folks that obviously want to implement a shared storage solution that isn't gonna chew up the entire IT budget. I think that really what we're going to talk about in the next series of slides is going to offer a nice alternative, and I'll share with you why. Now, this is the iSCSI SAN. Now, this looks very familiar. I mean, it's the basics are the same here. You've got your application layer, and we've separated out it out from the storage layer. I think the main difference here is we're really focusing on the utilization of commodity hardware. So, as you can see here, instead of, proprietary fiber channel HBAs, we're using gigabit switching technology, so gigabit NIC cards in the application hosts. A standard gigabit switch that's going to serve as the iSCSI backbone or the communication network that's going to be used to allow these application servers to communicate with their storage. And then down below, again, commodity servers. So these are servers that you've got in-house. So a lot of you are looking at virtualization projects and are in a scenario where you're going to have a lot of extra hardware around that ultimately is not out of service yet. It can be repurposed, it can be reused, or you can go ahead and order hardware from your traditional vendor, whether you're a Dell shop, an HP shop, Supermicro shop, whatever the case might be. You're going to be able to go through the process of building out the storage boxes that are going to meet your needs and fit within your budget. And so, what we've got down here is, and by doing that and saving the dollars that are the dollar savings that are associated with that, we give you the ability to go ahead and start to consider things like highly available storage, which means I've got redundant storage nodes. The area of focus here is going to be on synchronous data mirroring with automated failover, the use of MPIO to make sure that your application layer does not lose connectivity with the storage layer if one of these nodes were to go offline, need to be patched, power supply needed to be replaced, etc. You'll continue to be able to offer that storage. So that is a scenario that in some of the higher end solutions can be very costly. Not only is the solution itself potentially a bank breaker for a lot of us, but you start getting into some of the additional features and functionality in those SANs. And with iSCSI, we're sort of lowering the bar a bit from a cost perspective, but maintaining performance and really the overall reliability of a solution. So that leads us to sort of our next point, in the discussion around central storage versus direct attached storage, or shared storage versus direct attached storage. And a lot of you wonder, why consider a SAN implementation? For the most part, we're really talking about more effective management of storage resources. So you may think that you're going to have X growth on a given server, and you may put a terabyte or 2 terabytes in a given server. It's locked up in that one server, and if you don't use it, it's sitting there, it's wasted. The same thing with maybe server 2 or server 3. You've got a lot of storage tied up in these servers that's ultimately being wasted. The shared storage, or the SAN model, allows you to go ahead and add storage as it's needed to the storage layer and ultimately parse that storage out. So it's a much more efficient model. You don't have storage sitting around waiting to be consumed. You've basically got storage that you can continually add to the storage area network and simply parse it out as it's needed, and be a lot more efficient with your storage management. The other piece is the data level protection. So you start getting into block level SAN volume mirroring or block level snapshotting, which is a lot more efficient than doing a lot of the stuff at the file level. So a lot of the data protection features can be handled down at the SAN level, as opposed to having to worry about putting that additional pressure on the application server. And then obviously, we start talking about, unlocking some of the application's enterprise features. So we start talking about, in this case, the focus of today's conversation is around VMware. But we're talking about things like DRS, vMotion, storage vMotion. So in DRS, the distributed resource scheduler. So the ability for ESX to load balance VMs across multiple hosts in a cluster. Your ability to go ahead and live migrate or migrate a VM from one host to another without taking it offline, or to change the storage repositories that are being used by a VM without taking it offline. Then we get into fault tolerance and high availability. So the ability to go ahead and set it up so that if one of your VMware hosts does die, it will spin up on a second host or a third host or a fourth host without any manual intervention. All of these features are really critical to a lot of us, but cannot be accomplished without the shared storage model. And obviously that means that no shared storage, which is no cluster, which is none of these particular enterprise class features can be applied to your virtualization environment. Now, when we start talking about, SAN software and building a SAN to meet your needs, we're talking about taking something like StarWind. There are other vendors out there, but something like StarWind that's going to help you build out your SAN using the equipment that you can afford. So one of the nice things that I like to preach here, and if I can get on my soapbox for just a second, what we're doing here is allowing you to customize a solution based on the budget that you have to build out this shared storage model. That is, we're going to continue to allow you to buy hardware from your hardware vendor. We're going to continue to allow you to go ahead and utilize an operating system that you're familiar with in Windows. All of this equipment is commodity-based equipment. So it's switches that you've managed in the past. It's network cards that you're familiar with how to set up and manage. Really giving you the option of how you're going to build out this SAN, and more importantly, bring it in for a reasonable price. So you're not having a vendor tell you, okay, you can have X amount of storage, it's going to cost you this amount of money. And if that's outside of your budget, there's no real wiggle room there. That's not the case when you start talking about SAN software. Why iSCSI? And I think this is obviously something that is probably on a lot of folks' minds. Why should I consider iSCSI? Why is iSCSI a way for me to go when I've got either fiber channel setups out there, NAS setups out there? I think iSCSI gives you that great middle ground, and for a lot of us, this is exactly what it is that we need to get into shared storage. It's going to provide you with the performance because it's block level. It's very, it's going to move over a fast pipe. The performance that you need, it's going to be faster and more reliable than, say, NAS. It's going to be less expensive than fiber channel. So this is really the nice spot for a lot of us. Again, you've heard me talk about this before. We're talking about commodity hardware. So you're not looking at going out and spending money on thousands of dollars on training or bringing in somebody to manage this storage because it's a foreign operating system or it's something that it's equipment that you're not used to using. This is all done on non-proprietary commodity-based hardware. So from an iSCSI perspective, for a lot of us, it just simply makes sense. Now, I never know what my audience is going to look like, so I always try and make sure I include this slide just to make sure everybody understands when we talk about iSCSI, what is iSCSI? And so we're talking about traditional SCSI disk commands that are transmitted via TCP/IP. So basically, there's an initiator that's going to run on your application servers that's going to be responsible for connecting to that storage, communicating with that storage, taking those disk commands issued from your applications, encapsulating them in TCP/IP packets, transmitting them to the storage network or the storage layer in your infrastructure, and ultimately from there the iSCSI service on those boxes will go ahead and process those and then push them down to the physical disk. It runs as a service. In our scenario, from a StarWind perspective, the iSCSI protocol runs as a service, presents disk to the remote hosts. You've got a couple of different options here. They can be a physical target, or you can use our storage virtualization strategies, which high availability is part of, and we're going to talk about today. Running via commodity hardware, again, very, very important. You're going to be able to tailor this solution so that not only will it meet the performance needs, but you'll be able to bring it in for a budget using off-the-shelf server equipment. The benefits of iSCSI, obviously, and this has been a common theme throughout this presentation, but obviously familiar networking standards. These are all standards that you've utilized. You've been using TCP/IP and the equipment that goes along with it since most of us have started our career in IT. Things like replication and other protection features, specifically like high availability that we're going to talk about today, bringing those features in at a cost that you can afford. So not only are you going to get the storage area network for a reasonable cost, but you're going to get the features that you need to make sure there's no single point of failure in your environment for a reasonable cost. Eliminating the cost and overhead of proprietary hardware. Guys, I think we can all agree that fiber channel equipment, while it's tried and true, it works well, it's very fast, it is expensive. The equipment, the initial purchase of the equipment is expensive. Replacement equipment is expensive. It's not off-the-shelf stuff. You have to get it. You have to pay for it. You have to install it. You have to maintain it. Can't always be managed by existing staff. So that fiber channels, you may have to bring somebody in to manage that specifically. The other thing that I want to mention here, and this is also a very important point, I've spent the first part of this presentation talking about why you want to consider fiber channel over iSCSI. I'll also make this point very clear as well. iSCSI fits very well into mixed environments. If you're a customer that's already made an investment in a fiber channel SAN, certainly that does not preclude you from looking at iSCSI. I think that, as a lot of you know, those fiber channel SANs, they're meeting your needs. However, why spend additional dollars on expanding that when you've probably got information on there that doesn't need to be on there? Do your backups need to be stored on there? Do you have room for maybe a second tier of storage where iSCSI could be the right fit? So again, something else to consider. iSCSI will fit very well into that sort of tiered storage strategy that any of you may be considering if you've already got sort of a fiber channel or other type of shared storage model within your environment. Now, I also like to cover, before we dive into some of the other sort of practical pieces here, the performance best practices. So, things like, when you're setting up an iSCSI SAN, things you really want to consider, again, from a very high level. I will say this, any of you watching this that are interested in maybe discussing this in more detail, please contact us and we'll certainly talk to you about this in more detail. But, so starting with network isolation, configuring iSCSI network or a VLAN. So if you've got a very robust switch, we want to see a VLAN off the iSCSI traffic so that it's not competing for bandwidth with other applications, or in some cases where you can simply go ahead and isolate it via a separate or a set of redundant switches altogether. Use of dedicated NICs in the application servers, again, critical. This is, along the fiber channel model, only rather than using a fiber channel HBA, you're able to grab these commodity NICs, pull them off the shelf, slap them into your application servers so that, you've got a private network set up for the iSCSI LAN itself. 1 gigabit scaling to 10 gigabit. As we're starting to see more and more 10 gigabit, obviously iSCSI scales right up to that. But at a minimum, we want to see using a gigabit backbone. Things like network optimization, considering jumbo frames for network efficiency, TCP/IP window size adjustments. These are all things that we can talk about, or you can go ahead and reach out to us and we can give you more detail offline. Matching disk speeds with I/O loads. So configuring your RAID sets are key. So when you're configuring the storage in these SAN boxes, you want to make sure that you're considering the applications that are going to be serviced and configuring those RAID sets accordingly. So making the choice between RAID 5, RAID 6, and say RAID 10. Some of it could be budgetary, some of it could be data protection issues, but certainly making sure you've matched that RAID set properly. Use of proper disk, so making the decision between SAS and SATA, so the different types of drives that you're going to wind up using. And then matching RAID sets with I/O patterns. This is also a pitfall that I see a lot of folks fall into when we get into talking about the use of SAN. Making sure that you're not, say, and I like to give a quick example of, in the database realm, utilizing, looking at storage for utilization with a more transactional database, something that's going to put a heavy load, versus, something that's going to be much more sequential, like a data warehouse. Mixing those two I/O patterns on the same RAID set or on the same set of spindles could have really disastrous performance results. And so, you want to make sure you think these things through, and these are all items that we're certainly happy to discuss with you as we sort of move forward. And then lastly, the last bit of advice I give folks when it comes to performance is monitoring. You really want to make sure you're monitoring what's happening with the iSCSI pieces of this. So you want to monitor these boxes. Now there's a lot of great free tools that are out there to do this. I'll give a plug to Spotlight on Windows from Quest Software. A great tool to be able to go out and monitor the SAN, monitor the boxes, monitor things like disk queue length, memory overhead, CPU utilization, network utilization, all things that you want to keep an eye on and make sure you've got established baselines on, so that you're going to know if there's going to be a problem with the SAN prior to the users finding out about it via a performance problem with their applications. So, the other thing we talked about when we talk about SAN implementations are, the block level replication or the data protection strategies. One of which is obviously block level replication. This is for both HA, as we're going to see today, and DR strategies. These are all requirements that are easily met using iSCSI. Things like distance replication over an IP network, a WAN, or a VPN. So if you've got a requirement to go ahead and replicate your data to an off-site location, rather than try and do that at the application layer, you can do it at the volume layer or at the block layer with SAN technology. And then obviously high availability storage with StarWind 5.0, which we're going to take a look at today. Point-in-time snapshots, capturing block level changes made to a volume. This is a very efficient way to go about creating rollback points for yourself. When you start talking about having to go ahead and make sure you insulate yourself from data loss, and this is really about basically helping prevent the software-based failures or the data corruption type of issues or the malicious attacks, so that you not only have your last nightly backup, but you may have 2 or 3 restore points that you've created throughout the day. You can do that at the SAN level for a quick, easy rollback of volumes or doing file level recoveries. And then things like securing the storage. So, you've got this central storage model. You're using iSCSI initiators to connect to it. You want to be able to lock it down or secure it. So things like CHAP authentication to prevent unauthorized access at the storage level. IPsec to encrypt communication between the host and the storage controllers. And then things like lung masking to prevent the wrong server from servers that shouldn't be connecting to a piece of or a pool of storage from connecting to that storage, or being able to match up LUNs with specific servers. And then lastly, high availability via MPIO, which we're going to talk about today, making sure that you don't have a single point of failure at the SAN level. So as we're going to do now is sort of transition into the ESX resource cluster big picture stuff. So this is really where I want to talk about, setting up and what an environment might look like that utilizes, ESX within an environment with shared storage. In this case, StarWind high availability shared storage. Now, this is admittedly, a rudimentary diagram, and I've kept it simple on purpose. I want to be able to point some things out, specifically some things that maybe aren't on this diagram as well. So things like redundant switches. So as you can see here, I've got an iSCSI switch and I've got an interface to the corporate LAN for my VMs on this particular piece here. A lot of you that are striving or looking for 5 nines of availability from the customer side of things or from the user side of things may be building in redundant switches here, which is a perfectly acceptable scenario to prevent any single point of failure. But what we've got here is we've got our storage layer over here, and I've got my 2 StarWind nodes that I've basically configured in an HA set. So basically, as you can see, I've got StarWind Node 1, StarWind Node 2. And as I'm going to walk you through on the demo how to create these HA sets, you're going to see it's very, very simple to set this up. One of the critical pieces here, obviously, is the StarWind HA sync channel. If you're going to configure your StarWind boxes for synchronous mirroring and you really want to get that high availability, you have to have a dedicated channel between these 2 boxes for synchronization. This way here you avoid that split brain problem that you can run into within, say, a cluster. Now, obviously, this is a scenario where we're going to get automated failover and fail back with StarWind via MPIO, and we're going to talk about that in a little bit more detail in the next slide. But as you can see here, I've got my, in red, I've got my iSCSI networking, my iSCSI switch connecting these boxes to my ESX host in this particular resource cluster. So my red represents all of my storage networking, a private network between my StarWind boxes and my storage nodes. I've also got a network set up here, a private network, in between these boxes that I can use for things like, VMotion, etc. And then lastly, I've got a VM network that I can use to go ahead and link up all of the virtual machines that I'm running here to their prospective applications or to their prospective users that are out on the corporate LAN. So again, what I'm providing myself with here is, when you set these things up in a resource cluster, is fault tolerance here at the application layer. Not only do I give myself the ability to load balance these virtual machines using some of the VMware features like vMotion and distributed resource scheduler, but I'm also getting high availability. So if one of these nodes were to die, the virtual machines would spawn on the remaining nodes. I get the exact same scenario over here with my StarWind high availability. If one of my storage nodes were to die, or if I need to bring one of these storage nodes down for maintenance, the data the I/O will continue to be serviced based on the remaining nodes. So this is a very critical point here in pointing this out, in that you've got you're matching the high availability at the storage layer to what you're being offered through ESX at the application layer, and really putting yourself in a position where there's really no single point of failure. Now, we start talking a little bit about how does this work, and obviously when we go into the live demo, I'm going to show you in a little bit more detail in terms of how that works. However, if we look here, this is sort of a blow up of storage clustering using MPIO. And so as you can see here, we've got our synchronization channel between the two iSCSI nodes, and then we're basically, from the initiator side, in this case an ESX box, we're creating multiple paths to the storage. And so basically I'm creating a storage device with, let's say, a half a terabyte storage device, so maybe 500 gig here, 500 gig here on each one of these nodes. It's presenting to, via MPIO, the MPIO driver, as a single unified storage device here. Every write that's issued is issued simultaneously to both boxes, with a synchronization channel in between to make sure that these are staying in sync, that there's no data corruption. Everything that is written here is written on node 2 and vice versa. So we're constantly making sure that these things are in sync so we don't run into a problem. The worst case scenario, obviously, is that this synchronization channel were to break. You don't know what if writes that are here are committed over here, or vice versa. So you're not sure what you're getting if one of these nodes were to die. With that synchronization channel there and the ability to go ahead and present two separate physical pieces of storage as one unified device, we're able to achieve HA. There's no services that need to fail over here. So if box 1 dies, it's not like we have to wait for a service to spin up on node 2, which could prevent or present an I/O timeout problem. What happens is because we're utilizing MPIO here in an active manner, if one of these paths were to die, let's say the storage node were to die or the networking cards were to die on one of these boxes, I/O would just continue happily down the second node or the second path without any problems. And when we brought this node back up, we would just go ahead and synchronize in the background, and it would take all the data that was written while this node was down, push it across the synchronization channel, and bring this box up to speed. So these are all things that I'm going to show you here now, just as we go through this. So that's going to now represent my ability now to bring the theory into practice. So now we're going to get into the live demo portion of what we're doing here. To set the stage a little bit, I'll give you some sense for what I've got going on here. As you can see, I've got a 3-node storage or 3-node ESX resource cluster here. I've got some virtual machines that are running on this resource cluster. In particular, this 2003 VM1 is what I want to pay particular attention to. To give you some sense for what we're going to look at here while we go through this, we're going to look at the storage here, and I've got this ESX HAD99. If I look at the properties of this storage, you'll see that this is a multi-path storage device. Now I'm going to go over to the StarWind side and actually show you how I go about setting this up. But as you can see, I've got 151 paths of the storage and a .149 paths of the storage. So two separate storage devices. I've got ESX HAD7, ESX HAD7 Partner are my two targets that make up this highly available storage. Now, with that said, you can sort of see how this works from this perspective. Let me pop over to the StarWind side here and show you how this works. Now, as you can see, I'm logged into my StarWind boxes here, or my SAN boxes from the StarWind Management Console. Here's the storage devices that we were talking about earlier, and as you can see, I've got both the primary and its partner server are both synchronized at this point. Let me actually show you how I set one of these up. Now, obviously, this assumes that you've gone ahead and installed StarWind on both sides of this equation. You've gone through the process of not only getting StarWind installed, getting it licensed, and then obviously going ahead and configuring the physical storage in these boxes. So now that it's ready to be used with this HA virtual storage device. The next step that I'm going to take here, obviously, is once I've done that, I'm going to sit here on one of my iSCSI target boxes, and I'm going to go ahead and click Add a Device. Now, it's going to ask me for a device name. We'll call this Demo Feb 10 HA. And I'm going to go ahead and choose the storage type that I'm going to use for this, in this case hard disk. And I want to use an advanced virtual device, and then I want to go into the high availability device. Now, as soon as I select high availability, the first thing that the system's going to ask me for is what is the IP address of the partner server, or the other box that's going to serve as the HA set. 168.1.151 in this case. Root. So log into the service. It goes out and does a quick check to make sure that the service is indeed there, and it lets me know that it's going to set up a partner target, or a second target on that box. It's gone ahead and just added the word partner to the target name. Now I'm going to go ahead and choose which physical storage am I going to carve out to make up this HA set. So this is the current server that I'm on here, and I'm going to create a new virtual storage device. And I get to choose which set of spindles this is going to get created on. And we'll call this Demo 10 HA Disk 3. And I'm going to do the same thing on my partner server here. I'm going to create a new device. And it brings me to the file browser on the partner server. And Demo HA Feb 10 Disk 6. And I'm just going to size it. I'm going to create a small 100 megabyte volume just so you can get a flavor for how this works. Now, it's gone out and created those image files. Now what it's asking me for is the synchronization channel parameters. So how do I want to set up the synchronization? Now I've got to choose an IP address over which the synchronization is going to be used. This is really where, again, this is a lab environment, so certainly this is not going to be indicative of what you'd see in production. The recommendation that we make to our customers is that you have a separate channel dedicated to the synchronization. Where possible, make it redundant. If that's not possible, perhaps use a crossover cable to connect them directly. But I'm just going to go ahead and use the primary IPs on both of these boxes. And then it's going to ask me how do I want to initialize this set. Obviously, I've got two blank devices here, so I'm just going to go ahead and clear the mirrors. And next, and finish. So now, as you can see here, it's gone out and created these partner devices, or these devices on this server. So I've got this main device, and then I've got the partner device. It's gone ahead and synchronized them already. They're very, very small devices. So these are actually ready to use. This is all set and ready to go. So what happens next, obviously, is you're going to connect to this from your ESX environment. Now, for those of you that are utilizing ESX, all you have to do when you configure this, now you want to go through the process of setting up your ESX box for iSCSI. So that means enabling the initiator, creating things like your VM kernel port. So you want to make sure you've got a VM kernel port that's utilized for iSCSI. You want to make sure you've created the appropriate holes in the firewall for port 3260 on your iSCSI box, and then ultimately gone through the process of enabling the software initiator. Then what you want to do is you want to make sure once you've enabled the iSCSI protocol, the iSCSI software initiator, you want to then go ahead and make sure that you've listing the IP addresses under dynamic discovery of both boxes that make up your HA set. So in this case, I've got .149 and .151. So this is going to go ahead and scan both of those boxes for targets. It'll find both of the targets that are part of my HA set and present that as one unified piece of storage. So as you can see here, what the net result looks like is this. You've got ESX HA setup where you've got multiple paths to a single storage repository. So in this case here, I've got my scenario where I've got the path, the 151 path and the 149 path. My path selection when it comes to reads, obviously when it comes to writes, they're going to be issued down both paths, so we're going to have an exact replica on both sides. My reads, I can go ahead and configure it either via round robin, most recently used, or fixed, depending on sort of how you want to go ahead and if you want to load balance the reads across both machines. So that is set up there. So what's going to happen now is in the event that I do have a failure, and I can certainly simulate one of those by simply going ahead and stopping the iSCSI service. So I simply go ahead and stop it on this box. This is the 151 box, which represents one of the paths to my storage. I simply go ahead and stop that service. And as you're going to see over here on my main console, I lost connectivity to the 151 box. It's no longer connected. And that service should have stopped by now. Yep, it has stopped. So I have lost that particular iSCSI storage box. Now, it usually takes ESX a little time to catch up, but let me go ahead and open the console. This is a virtual machine. The virtual machine obviously is still going to be powered on. There aren't going to be any issues with the virtual machine itself. Because as I said, the I/O will continue to travel down the one remaining path that's available to it. So I can come here, and this is a virtual machine that's hosted on that storage. Simply log into that virtual machine. And as you can see here, I'm on Win 2003 VM1, which is this one right here, which is hosted on this particular piece of shared storage that is highly available. If I look in here at the properties, it will go ahead and refresh, and it will let me know that there's a dead path to this storage. As you can see here now, I'm only left with my .149 path to the storage. So, I've essentially taken out one leg in this whole thing. I can browse the data store here, and I can see 2003 VM1 is actually one of the virtual machines that's running on this particular piece of shared storage. And as you can see here, this particular piece of shared storage, this particular virtual machine is still operating, as it normally would. I can issue I/O to it by simply going ahead and saving that document. Everything's working the way it's supposed to. Now, when I bring that node back online, which I can do by simply going through the process of starting the iSCSI service again, coming over to my service console, relogging in. Now you'll notice all of the warning signs that have popped up here on my remaining node. This is letting me know that I've got an out-of-sync node. So my storage is continuing to operate. ESX is continuing to see this storage without any problem at all. I simply need to come in here, connect. Now what I want to do is I've brought this box back online. I can see here I've got an out-of-sync node. I can tell that by the little red exclamation point here on this particular piece. I can simply come in here and do a fast synchronization. Now what a fast synchronization is going to do is simply synchronize the data that's missing between the two targets. So it's going to go ahead and rather than synchronize the entire volume, it's just going to say I want to synchronize what's been missing. So it's going to go through that process of just synchronizing what's missing, and I can kick off fast synchronizations for these. And as you can see here, the exclamation points disappear as soon as the volumes come back into sync. So I can just spin through this and kick off fast syncs for all of these, and it will go ahead and resynchronize all of them. And we'll do that for the demo device we created. And we'll come down here. And now what I want to show you is now that we've brought that storage back online, we can come over and we can look at the properties of our data store, and we can look at the paths to our data, and now we're back to 2 active paths again. So now we're back to full strength. So really, when you think about this, not only is shared storage going to create a scenario where you can do things like migrate these virtual machines. For instance, I can come down here and migrate this VM. I can change the host to a different host, any host in my cluster. I can migrate the storage. I can let DRS, or Distributed Resource Scheduler, decide which hosts these virtual machines will run on based on their resource consumption, all through utilizing shared storage. The real benefit here is we no longer are going to be constrained to creating a single point of failure through that shared storage. As you can see here, I've now got two specific boxes that are utilized for shared storage in an HA type of scenario. So now if I have to bring one down, or God forbid one comes down that's, I wasn't expecting, someone pulls the plug, the power supply dies, my operations will continue without any disruption whatsoever. So that's really all we had to present today in terms of showing you shared storage, highly available shared storage with ESX. I want to thank everyone for joining us. Today's presentation was recorded and will be available online within the next 7 days or so. So if you have any questions, issues, would like some more information, please feel free to contact us. You can simply email us at sales@starwindsoftware.com, and we're happy to get back to you as quickly as we can. I appreciate everyone's time today, and hopefully you got a lot out of today's session, and we can take it from there. Thank you very much.